In this video, I'll be going over how to connect a Postgres database to our FastAPI application. FastAPI is a modern, fast, high-performance web framework for building APIs with Python. I expect you to have a running Postgres database, but just in case you don't, I'll show you how to get one running with Docker. So if you don't have Docker, I'll leave a link in the description. Alright, so here I am in the terminal. Now to run a Postgres container is pretty simple. We'll utilize a one-liner using the official Postgres image. Make sure that Docker is running. And for Mac users, you usually can see a well on your top bar. So if I go here, I should be able to see a running well that says Docker desktop is running. But you can also check in your terminal using the Docker command like docker ps. And that'll show you any running containers. Right now I have some Kafka containers running and Zookeeper container running, but we don't have a Postgres container running, so that's what we'll be creating today. Now, if you don't have any running containers, you won't see any containers, obviously, but if it does pop up like container ID, image, command, or anything really, then that's good because that just means that Docker is running. It wouldn't let you run the command if Docker was not running. So let me clear that out, and let's go ahead and create the Docker container. So what I'll do is docker run -- name, and I'm going to call the Postgres container Postgres-db. And then I'll use the -e to define a environment variable. And the environment variable that I want to set is the Postgres _user, which will define the user name of the Postgres database. Then the next environment variable that I want to set is the Postgres password. So that's going to be Postgres _password, and that's going to be equal to password. Now obviously this is going to be a local running container. This is not going to be production grade, so obviously it's not a strong password. If it was a production grade Postgres database, obviously you want to use a stronger password than this. Just a disclaimer. And the next thing I want to create is the port of which this Postgres container will be running on. And I'm going to use -p, and I'm going to define 5432. Now this just means that it will be exposed on the host machine on port 5432. So any request sent to the host machine on port 5432 will be forwarded to the next port that we'll define, which is going to be inside of the container running, which is going to be 5432. So anything on our host machine that gets sent to 5432 will be sent to the internal port of 5432 of the container, which will be our Postgres database. And then we'll use the -d command to define that this is going to be running detached, meaning this container is going to be running in the background. And we got to define which image we're going to be utilizing to construct this container, which is going to be the Postgres image. Press enter. You should see now this long little hash, and if we do docker ps, we should now see that right here it is running our Postgres container. And you can see that the ports here is 5432. It's going to forward it to 5432 as you see here using a TCP connection. And you can see that the Postgres container name is right here, PostgresDB, as we defined here. And we're going to use the username that we define in the environment variable of Postgres _user and the environment variable of Postgres _password to log into our Postgres instance. Now if you want to get more information regarding the Postgres image, I'll leave a link to the Postgres image on Docker Hub, which will give you more information on versions and different environment variables that you can utilize to run this image, right? So you could go here to the environment variable section and you can define some other variables that you want to utilize. And it also gives examples of how you can use this with Docker Compose to connect Postgres to other things, right? Utilizing a network, or just to see how to run it using a Docker Compose, or even just how to run it with just a one-liner like we just did. Or if you want to just know more information about Postgres, there's a little section on that as well. So I'll leave a link in the description to this page. So open up your favorite editor and terminal and let us set up a virtual environment. Here I have Visual Studio Code. I already have my folder set up, and I have a terminal opened up to create the virtual environment. Now let me give my little spiel on virtual environments. Virtual environments will allow us to download dependencies within a confined area instead of globally installing dependencies. It's perfect for cases where you want a consistent versioning of dependencies used in your application, so that maybe you want to share with a team member, they will also have the same versioning. Or maybe you want to move your application to another machine, maybe going from laptop to desktop or going from laptop to another laptop. You have a consistent confined area of dependencies that you can utilize for your application instead of having it downloaded globally and all your applications are using the same dependencies, the same version of dependencies. You have a now more strict area of dependencies that you can use for that specific application. I have a separate video explaining all about it. I'll leave a link to that video somewhere on the screen. For now though, let's create a virtual environment. So for me, I'm going to do Python 3. Maybe you have a different alias, you could just use Python, but for me it's Python 3. I'm going to do -m VNV, and I'm going to provide the name of the virtual environment. Now if you want to call it Bobby, you could do that, but usually I just keep it as VNV just to make sure that I know that this folder that's being generated is a virtual environment. So I can press enter and it should create the virtual environment, and Visual Studio Code is nice enough to ask us, do we want to activate this virtual environment? Well, I would love to, but let me do it manually. Now to do it manually, all I got to do is do source /bin/activate and press enter. And in this bash terminal, I can see that VNV is activated based on this little parentheses that shows VNV. And the cool thing about it, if you forget like the bin and activate part, all you got to do is open up this folder and you can see that the first folder says bin and you can see activate, right? That's the little shell script that pretty much creates the virtual environment for us, right? It activates it for us, and to deactivate it, you can just do deactivate. And you can see that it disappears. But I want to keep it activated, so let me do the source VNV bin activate again. And that // just means that it's this current directory. Like this current directory is holding this VNV. So if it's further out somewhere or a little bit, if it's in another directory before this one, then you would have to adjust this directory a bit. But since it's in this current directory, I can just use //. Now, if you're on Windows, I didn't forget about you guys. So for you guys, let me clear this out. It'll be source, and then it depends on your folder structure, but let's say it's in the current folder, it'll be /VNV scripts and then activate. And that's how you'll do it on Windows. And say for instance you don't know if it's activated, it doesn't show this, you can check by doing which Python, and it'll show you which Python is it using, and it's showing and directing it to the Python in this FastAPI DB folder, which is just this one right here, right? So it's pointing to our virtual environment, which is good. So now that we have our virtual environment set up, we can now install all the dependencies we'll need to connect our application to a Postgres database. So let's do that. Let's do pip install FastAPI, open up some brackets, standard, close the bracket. Then the next dependency I need is SQLAlchemy. Which will allow us to create some tables using classes, which would be very beneficial for us because we want to check if our connection is established and that we're able to create tables. So I'll show an example of actually creating a table in this setup. And the next thing I'll need is psycopg2-binary. Now, just a disclaimer, psycopg2-binary is good for development purposes because it doesn't require as many dependencies, but psycopg2, which is without the binary, is recommended for production grade applications, but it will require you to install additional dependencies. But since, like I said before, this is for local usage, I'm going to use the -binary to get a less dependent version of psycopg2. Press enter and it should begin collecting all we'll need and installing the dependencies into this virtual environment. And you can also see that FastAPI comes with a lot of additional dependencies, and you can see, and honestly, we probably didn't even need to install SQLAlchemy. I see that it already included it, but just in case. And also, let me see, there's another one, if I can find it, Pydantic we'll be using to create some schemas to help structure our application, but is within the install of FastAPI. All right, let's go ahead and create the main.py. This will be the entryway to our application. This will be where we initialize and connect everything in this application. So with FastAPI, it really doesn't take much to get something functioning, which is why the name is FastAPI. So let me head and create a new file called main.py. And really, it doesn't really take much to create a running API with FastAPI. The name actually prevails. So let's go ahead and do from FastAPI import FastAPI. And here we'll have a variable called app that will equal to the instance of FastAPI. And to create a running route is going to be easy. All we got to do is @app, use an HTTP verb, which it comes with a lot, but we're going to use get, and we're going to provide the name of that specific endpoint, which we're going to do /health, which is going to be like a health check. And I'm going to call this def health underscore check and open up some parentheses. And we're going to define what we're going to return from this endpoint. So we're going to return a status, right? A status that this is running. So I'm going to create a nice little dictionary with the key of status and that it's running as the value. Let me go ahead and run it. So let's do FastAPI dev main.py. Press enter, and boom, it starts it up. And now it lets us know that it's running in development mode, but it's serving it at port. First of all, this is the IP for localhost, and it's running it at port 8000. And the cool thing about FastAPI is that it automatically generates documentation for us. So we can go to localhost 8000 /docs, and we can take a look at our documentation. So here I am in the documentation, and we actually see our health check right here. So if I open this up, I can see that I can try this out. I can send a request using execute. And what do I see? I see that it returned a status of 200 with the status of running in the same format that we return from the endpoint. So like I said, just as the name implies, this is a way to generate a very fast API. And if you want to run it a curl command, you can do that as well. You can just copy this and run it in your terminal if you want, but you can also run this through your documentation. But let's actually get to what this video is about, running a database, connecting to our Postgres database. So let me go ahead and create a new folder called app. I'm going to create a new folder within app called core, and I'm going to create a new file called database.py. This is usually the file structure that I use when creating a connection to the database. I usually create a parent folder of app, then I create a core that holds the core information about the application, and I place things like security and database information here. But you're free to use whatever structure that you want. Now in this file, we're going to need a couple of imports. So I'm going to import from SQLAlchemy, which we import create engine from SQLAlchemy.ext.declarative import declarative base, and from SQLAlchemy.orm import session maker. Alright, so the first thing I'm going to create is a constant called SQLAlchemy underscore database underscore URL. So this URL string is just a connection string that's going to allow us to connect our Postgres instance with our SQLAlchemy. So to start off, we got to do Postgres SQL, and it's going to be a : 2/. First is going to be the user, which we generated it with the environment variable when we created our container, and that was user. Then you got to put a : and then define the password. So that's going to be password at select the host. So in this case, the host machine is localhost, and we can forward it to the port of 5432 by putting a : 5432 and then defining a database. So in our case, the database by default is going to be Postgres because when we created the container, Postgres by default creates a Postgres database, so we can use that. Or you can create a database within the container, and you can define that database here. Now, like I said, this is all local, but conventionally, you would want to create a .env and inject the variables into the string. You don't want to directly put it like I just did. You want to create a .env and inject it into here because it's important. This is holding your data, and you don't want anybody to be able to see this. So for speed purposes and just for local usage, I just inject it right away into the string. But just a disclaimer, use the .env and inject it. Then the second thing I'm going to create is the engine, right? This is going to be using the create engine, and the engine is the starting point for any SQLAlchemy application, right? Just like a car is the start, is how the car starts. This is how SQLAlchemy is going to start. And I'll create a variable called engine, and it's going to be equal to create underscore engine with the URL we just defined. So SQLAlchemy underscore database underscore URL. It's going to try to create that engine, start that engine using that connection string. Next, we're going to create a session, right? We're going to implement a session using the session maker. This is what's going to allow us to interact with the database. So I'm going to call this session local equal to session maker, and we're going to define some properties of this session maker. We're going to say that auto commit is going to be equal to false. I don't want to automatically commit. Auto flush, I don't want to automatically flush, and it's all lowercase. It's going to equal to false, and we're going to bind it to the engine because, like I said, this is going to be how we interact with the database. So we're going to bind it with the engine, and then we're going to create a base class for declarative model. So this base is what's going to help us create our tables just by using Python classes. So it's going to inherit from this base, and it's going to allow us to construct the tables just by using a class, which we'll see very soon. But we have to use a variable to hold that, and I'm going to call this variable base, and it's going to be equal to declarative base. And then next, we're going to create an instance of session, right? So we're going to create a function that's going to allow us to get an instance of a session by just injecting it where it needs to be utilized. So this is going to be helpful for things like routes, where we can inject a instance of a session to allow us to interact with the database, right? Or maybe we need to pass on a session to other classes or other instances of a class, which is an object. They might need a session to actually create the object. So having a function that's going to allow us to grab an instance of a session to interact with the database is very important. So let's define this. So I'm going to call this get underscore db, and what I'm going to do is I'm going to make the db equal to session local, right? An instance of session local, which is right here. This is, it creates a session for us using the session maker. And what we're going to do is we're going to do try, and we're going to yield the db. So SQLAlchemy has a connection pooling mechanism by default. This just means that with yield, you're creating a single session for each request that needs a session. So we don't want it to just be one session that the whole application uses. We want to be able to provide a session for anybody that needs it, right? So if one endpoint's needed to create a call to the database, another endpoint needs it, another repository needs it, another service needs it, then we could create 4 sessions instead of just one single session, right? So that's what this yield db allows us to do. So we'll have that here, and then finally, when all of that is done, we can close that instance. So cool. This is the database.py. This is how we configure it. This is how we start up the engine and provide sessions to other areas of the application, and where we created the base that will allow us to create a table by just using a class, which we'll see soon. Now, in this app parent folder, let's create a new folder called db, right? And another folder I'm going to create is a model folder, right? It's going to hold our models that will be used to create our tables. because we need to create a class that's going to structure how the table is going to be defined. Because remember, like I said, we can use base to create an instance of a table by just using a class, right? The class is just going to hold the properties of the table, and base is going to allow us to generate it, right? If it inherits base, then we can generate it pretty easy. So in the models folder, and I made a mistake, it should be models with an S. Let me rename that S. In here, I'm going to create a new file called user.py because I want to create a user table. So from here, I'm going to do some imports from app.core.database import base, because like I said, we're going to need that. And then from SQLAlchemy, import column, integer, and string. Now what I'm going to do is I'm going to create a class called user, and I'm going to make it utilize the base class that we created, right? Because I want this user class to define a table. So I need base. I need that declarative base. And I'm going to change the table name. So I'm going to use 2 underscores table name, then another 2 underscores, and I'm going to make that equal to users. Now I'm going to define some properties for this class, right? And that's going to make it columns in the table when it actually generates the table. So the first thing I'm going to create is the ID. I need a unique identifier for each individual being stored in this user table. So that's going to be column, which we imported here, and it's going to be of type integer, and this is going to be the primary key because I want this to be unique, and I want this to increment every single time we add a new user to the table. So this is going to be the primary key. This is going to be the primary identifier of this table. It's not a plus. Made a mistake. It's equal. But this is going to be the primary identifier for this table. The next thing I want to create is the first name. I want the user to have a name, and I'm going to separate the name by first name and last name. So it's going to be first underscore name. It's going to be equal to a column, and it's going to be of type string. And we could define how long or the max length of the first name. So in this case, I'm going to make the max length 50, and then I'm going to steal this, all right, and I'm going to provide that as the last name. Oop. So last name, and I've seen some very long last names, so I'm going to say the max last name is going to be 100, and then the next one is going to be email. So I copied that again and pasted, and it's going to be a string of 70. And another thing I want to make sure is that I only want one person or one user to be able to use an email, right? I want each user to have different emails, so I'm going to make this unique, so I can just define that it's unique. It's going to be true, right? Only one person can have this email. Only one person can have this ID. It is a primary key, so it's going to make sure that it's unique. And then for password, same concept. I'm going to paste that in to change the name to password. And for the length, I'm going to make this bigger because in the future I intend on hashing the password, and that can get pretty long, so I'll define it as 250. So cool, now we created the structure of the user table. When it actually generates the table, this is how it's going to look like. It's going to have a unique identifier of ID that works as the primary key. We're going to have a first and last name, which is going to be a string. First name has a max size of 50. Last name has a max size of 100. Email is going to be a size of 70, and it has to be unique. Only one user can have that single email. Multiple users can't have the same email. And there's password, which is going to be the length of 250, the max length of 250. So we can save that, and we're good to go. Now, it doesn't automatically generate the tables like magic. We actually do need a couple of things to help us create the tables into our database, but this at least structure it for us. So to actually generate the tables, we can create a utility folder within this app folder. It's called a util. And inside that util folder, I'm going to create a file called init, and I'm going to use a lowercase I, init underscore db.py. And in here, I'm going to need a couple imports. So from app.core.database import the base, and we're going to also need the engine. And then also from app.db.models, we're going to import the user. Now, why are we importing the user? Well, you have to import the models you want to be created. So you need to import whatever models that you want to be generated to create the tables for it. So in here is going to be a pretty short function. We're going to call it create_tables. And all we got to do is base.metadata.create_all and bind it to the engine. So all this is going to do is, and it's metadata, so at the end it's an A, not an E. And all this is going to do is, if it has that base that we inherited from, and you imported it into this file, if the table is not already generated, when we call this create tables, is going to create those tables. It's going to create all those tables using the properties that you defined in that class. So we should be good to go on that. And now we just have to call create tables. Now, what would be a good place to call create tables? Well, let's go into the main.py, because I remember I said in the beginning that main.py essentially ties everything all together. And I think this will be a great place to actually call it. And when should we call it? Well, now every time we start the application, we need to make sure that we create the tables. That'll be the perfect time to create tables, right? Before the application starts, because we want to make sure that the tables are created to actually start querying the table when the application does start, right? Because we need to grab information, or we need to create information in those tables, and we got to make sure that they actually exist to do that. So FastAPI has a thing called lifespan. It will execute the code before the application starts to take requests. And you're able to close any code or clean up any code at the end of the application. So if you have anything that you need to close, like a database, or if you need to close any events, you could do that using a lifespan. So the name pretty much speaks for itself. It's like a lifespan. At the beginning, it does things, and at the end, it closes things, like it ends things. So let's go ahead and utilize that. We're going to need a couple of imports though. So let's do from context lib import async context manager, and then from app.util.initdb import create tables. So now we actually had to define the lifespan. So make sure you do it before the instance of FastAPI. Let's go ahead and do @async context manager. We're going to define an async function, and we're going to call it a lifespan, and it's going to take in an instance of FastAPI. We're not going to use it, but it's going to be there. And I'm going to leave a comment here that says initialize DB at start. My typing is not the greatest today, but let's go ahead and do create tables. Just call it. It's a function, right? So here it's going to attempt to create all functions that inherits the base that we imported in the file. So in this case, it's only user, so it's only going to attempt to create user. Before the yield is going to do things at the start, right? And after the yield is going to do things at the end. So if you want to do things before the application officially starts, you can do it here. If you want to do things as the application closes, you can do it after the yield. Cool. So like I said, this is like a separation point. So like I said, after the yield is when the application is closing, and it's really good for cleaning things up. Maybe you have some tasks that were running in the back end, or any DBs that you want to close. You can do that here. But yeah, it has to be after this yield. Now we actually have to make sure that we connect the lifespan to our application. So what we can do is, within this instance of FastAPI, go ahead and do lifespan is equal to the lifespan that we just created. Now all we got to do is run the application. Honestly, it was already running, so you can see that the Pi cache was just generated, and I can honestly just put a comment here just to make sure that you guys see that this was called at the beginning. So let's go ahead and save that, and look, waiting for application to start up, I can see that it printed created and the application startup then officially completes. So I know at that point that it got to this point and create tables was called, but let's actually see if the tables is actually created, or in this case it's just one singular table. But let's see if the table was created by going into our Postgres container and interacting with our database. So let's go into the terminal and do that. So here I'm going to create a new terminal. I'm going to clear this out, and I'm going to do docker ps, docker ps, and I'm going to grab this container ID of Postgres, and let me clear this out, and I'm going to do docker exec -it, provide the container ID, and I want to use bash, so I'm going to do /bin/bash, and then press enter. And now we're inside, and I can connect to Postgres using the psql-u, which is going to be the username. And remember, we created a username of user. In my case, if you use another username, then you have to provide that username here. -d will be the database name, which by default Postgres creates a Postgres database, which we utilized. So I'm going to put Postgres here and press enter, and here we are inside of Postgres, and you should see that here it says Postgres. Now if we want to list the tables, all we gotta do is /dt, and boom, we see users table, owner is user. Now if you want to see some information regarding the table, you could do /d, and if you use capital letters, then you have to use quotes and do users, which in my case is the name of the table, and I can press enter, and boom, I can see information regarding the table. So I can see ID, first name, last name, email, password, and the type that each column has. So integer for ID, and the rest are character with varying size. And the ID can't be null because this is going to be the unique identifier for each user, and it has a sequence which is going to increment the value of the ID for each additional user. Cool. And I can see that there's some indexes. This is a primary key, so there's already an index for that. But also I can see there's a unique constraint for the email because I only want one user to utilize one email, right? Each user needs to use a different email. Perfect. So we can see that we're able to connect with our Postgres container, and we're able to create tables pretty easily just by using a class. So that is how you connect your FastAPI application to a database.